The properties of gases.
Gases surround us all the time, in the air and in you. A form of matter which takes the shape and volume of its container, gases enable us to do the simplest things, such as playing basketball, listening to music, and smelling molecules in the air. To understand the properties of gas, first we need to understand the kinetic molecular theory. This theory states that molecules have no volume, and gas molecules exert no force on each other until they collide. Also, collisions of molecules with each other or the walls of the container do not decrease the energy of the system. The molecules of a gas in the container are in constant and random motion, and lastly, the temperature of a gas depends on the average kinetic energy. Or in other words, the energy of the ideal gas is entirely kinetic.
You know the sound a soda bottle makes when you open the container? That's the sound of compressed gas being released.
Molecules are different depending on the state of matter that they are in. For example, gases have an indefinite shape and an indefinite volume, but they are easily compressed. Liquids have an indefinite shape but a definite volume and are not easily compressed, and solids have a definite shape and volume and are not easily compressed.
Compressibility is that allows us to fit a lot of gas into a relatively small container. Why does this happen? Well, compressibility is a measure of how much the volume of matter decreases under pressure. Gases are easily compressed because in most cases, the individual molecules are very spread out. So with high levels of pressure, we can compress gases into containers.
Compressibility is a great property of gas that allows us to protect ourselves from fires and unpleasant classmate body odors. There are many factors that affect gas pressure, which include amount of gas, volume, and temperature. First of all, we need to know what pressure really is. Pressure is the amount of collisions on the wall of a container. This should tell us why amount of gas affects pressure. In a container with less gas, the particles hit the wall less often, but in a container with more gas, the wall is getting hit much more often. As particle number goes up, pressure does too. Actually, if you double the particles in a container, you actually double the pressure. This is because they're directly related. But be careful not to burst your container, because while compressibility helps us fit a lot of gas into a container, enough pressure will cause it to blow. Volume also greatly affects gas pressure. As volume goes down, pressure goes up. This is because with a small container, it takes less time for a particle to hit one wall and hit the other. But if we use a larger container, it'll take an even longer time to hit one wall and the other. Temperature has a similar, different effect on pressure, because as temperature goes up, pressure also goes up with it. As a gas is heated, the temperature increases, and the average kinetic energy of the particles in the gas increase. This really means that gas particles speed up and manage to hit the container's walls at a much more faster rate. This is precisely why we don't put high-pressure containers in high temperatures or or under heavy pressure.
Ivory soap. Without packaging, whoa.
Since ivory soap has gas pockets in it, it expands in heat.
Getting ready for the build-up. Okay. Da-da-da-da. Da-da-da-da-da. Da-da-da-da. Da-da-dun-dun-dun-dun-dun. Da-da-da. Da-da-dun-dun-dun-dun-dun-dun.
That cray-cray. That super cray-cray. Oh my gosh. It's like cray-cray in there. Ivory soap transformed to super cray-cray thing.
You may ask, how did it transform? Well, I'm here to tell you that. As you can see, inside the ivory soap, there were many gas pockets. And in these pockets of air, there were many gas particles. As we heated up the temperature in the microwave, the gas particles started to move at an extremely rapid pace.
When they did this, they built up enough pressure to just burst their containers, causing Super Cray Cray 3000.